11.
Yeah. So we are going to start with the new chapter. Chapter number 11, work and energy. And today in this chapter, we will be discussing these all topics. What do you mean by work? What is the scientific conception of work? How to find a work done by a constant force? And we will discuss few numericals on the work done. Okay. Yeah. So first of all, let me ask you one question. If I will say you, okay, for example, you all have heard about the word that is homework. Okay. And generally, what homework do you get? Your homework can be writing 5 to 10 questions. Okay. Your homework can be to read 2 pages of textbook. Your homework can be from other subject. It can be drawing or some picture or something else. Okay. So generally, homework means, especially it is because you are doing at your home, it is homework. But there is a word work. So all these acts like reading, writing, listening, okay, this all are termed as work in our daily life. Clear? We term this acts as work in our daily life. But in case of physics or in case of science, the definition of work is completely different. The definition of work is completely different. It doesn't have to do anything with that. Okay. So let us see what is the scientific conception of the work. So here the work is said to be done only when a force acts on an object and the object is placed in the direction of force. Like you can see in this figure that a force F is acting on the block which is placed on the table. So of course that block would move by some distance, and say that the block has displaced or it has covered the distance D. It has covered the distance D. Okay. So we will say that yes, the work has been done on this block. Is this clear? So very simple meaning of work done is a force should be applied on a body and the body should move or it should cover some distance because of that force. Only then we will say that work is done. Okay, understood? And as we have discussed in the previous chapters that in those we have discussed 3 equations of motions, and you all may be knowing that distance or displacement is generally denoted by the letter S. So here also we will be denoting this displacement by letter S. So according to that, our formula of the work done becomes work done on an object is the product of force applied and the displacement. It means it can be written as W work done equals to force into displacement, that is W equal to F into S. So this is the formula which we will be using for finding the force. Okay. Now, what is the SI unit of joule? SI unit of work? The SI unit of work is joule. Okay. And this unit has been kept on the name of a scientist whose name was James Joule. He was a British physicist who has done a lot of work in thermodynamics and even in physics in this field for force and these things and related terms. Okay. So this is the SI unit of work done, and you should note that it should be capital J. Small j nahi likhna hai, it should be capital J. Then, so now according to this formula, okay, one more thing. We know that what is the unit of force? It is Newton, and distance is measured in Newton meter. So according to this, the work done becomes Newton. Sorry, the unit becomes Newton meter. Okay, so it means what we can say that when force of 1 Newton, if F is 1 Newton and the body is displaced by 1 meter, then the work done is 1 Newton meter or 1 joule. Okay, let me explain you more clearly. Say if we are applying a force of 1 Newton, right, on an object, and the body also displaced by a distance of 1 meter. So by putting the values in this formula, this one and even the S is 1. So 1 and 1 will give us what? 1 joule. So it means what? Suppose you applied a force of 1 Newton on an object. Suppose you applied a force of 1 Newton on an object and the object moved by 1 meter. ऑब्जेक्ट कितने डिस्टेंस से मूव हुआ? 1 मीटर से. तो हम क्या बोलेंगे? वर्क डन कितना हुआ? हमने कितना वर्क डन किया? 1 जूल. Is this clear? If suppose on applying a force of say 2 Newton. Wait, if suppose we applied a force of 2 Newton, the body moved by a distance of 3 meter. Then what will be the work done? Find the work done, all of you. The work done would be
5.
5. Array, we have to multiply.
Sorry, 6.
6. Okay, in this formula, we will write 2 into 3. That will give us
6
Newton. Okay, like this. Understood? Okay. So even this is the same thing, that 1 joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter. That's it. Okay. Again, a example is given over here, that if a force of 5 Newton acts on an object and the object is displaced through 2 meter in the direction of force, then what will be the work done? So it's very simple. We just have to use the formula W equals to F into S. 5 to the, it will give us 10 joule. We will be using this unit, always we will be using the unit joule. So remember that though Newton meter is also one of the units for work done, but we will be using joule. Okay. So
Yes, sir.
you have to remember 3 things from this. First, the definition. Second, the formula. And third, the unit. That's it. Okay. Yeah. Now the next question. Sign convention for work done. Sometimes the work done can be positive, it can be negative, and it can also be 0. The work done can also be 0. We will discuss each case, okay, for positive, negative, and 0 work done. Now, when it is said that work done is positive? So work done by a force is positive if the force and displacement are in same direction. For example, you can look this figure number 2. That is the second figure. Earlier, the table was somewhere here. Can you see a very light figure of this table? Okay, the table was somewhere here. Okay, and even you can see a lady over here. Okay, this lady is pushing the table. This lady is pushing the table. Means she is applying a force towards right side, and even the table is moving towards right side. So in this case, is the direction of force and direction of distance or the displacement same? Yes.
Yes.
Are both in same direction? Okay. So in such cases, we will say that work done is positive. Work done is positive. Understood? It is very similar to that. Suppose if you are pushing some bicycle from behind, or if you are shifting a table, or if you are shifting a chair or any box, then you push it. And when we push it, it moves in that direction. Okay. So that means we are doing a positive work done. Now, what are the cases for negative work done? So for negative work done, the statement is the work done by a force is negative if the force and displacement are in opposite direction. Now, which are such cases? See, suppose there is a football which is rolling on a ground. A football is rolling on a ground. So after covering few distance, the ball will stop, right? After covering few distance, the ball will stop. So can you tell me that by which force the ball is going to stop? Or which force would be acting on the ball when the ball is rolling on the ground? Yes, anyone? If a ball moves on a ground? Yes, Tanush, but Sai,
Backward force.
which one?
Backward force.
Okay. What is the name of that force? Nimisha, Deepika?
Friction.
Frictional.
Frictional force. Yeah. Whenever an object
Friction.
moves on a surface, a frictional force acts on it. So say that this is a frictional force. And we know that frictional force always acts in the opposite direction to the motion of body. Right? So because of this frictional force, the object has covered, say, a distance of uh, s meter, or say a distance of 5 meter, and then it stopped. So in this case, the motion of force and the direction of force and direction of motion of body is opposite. Is this clear to everyone? Okay. So in such case, if it is asked that what is the work done by a frictional force, then you will be writing W is equals to minus F into S. Why minus F? To show the direction of force is in opposite direction. Okay. And whatever may be the value, suppose for some value of F and S, say if the value of F is 5 Newton and value of S is 2 meter, then it will give us minus 10 joule. Okay. So this is how the work done becomes negative when the force, direction of force and direction of displacement is opposite to each other. So hope it is clear to everyone.
Yes, sir.
Yes, sir.
There is
Yes,
one more
sir.
example for the same. Suppose a ball is thrown above. A ball is thrown above. So when a ball is thrown above, the ball is going to move in the upward direction. But at the same time, the gravitational force would be acting on it. That I am denoting gravitational force by F of G. So this gravitational force would be acting on it, and it is going to act on the in the downward direction. Means again it is in the opposite direction. So if it is asked that what is the work done by gravitational force on the ball, so in that case, whatever according to the value, we will according to the value of distance covered by the ball and the applied force, we will get some number. Say the number is 50. Let us take the number be 50. But what can you say? It would be positive or it would be negative?
Negative.
It would be negative. Why? Because direction of ball is upward and direction of force is downward. Means they are in opposite direction. That is why. Understood all of you?
Sir, your voice is cracking.
Yes, sir, your voice is correct.
Okay. So we discussed the examples of the negative work done. Okay. Now the work done can be zero also. And there are two cases for work done for which the work done becomes zero. First case is this one. Work done by a force is zero if there is no displacement. If there is no displacement. Okay. Means suppose if uh, say that a boy is continuously pushing a wall. If he is continuously pushing a wall, so he is applying a force. He would be applying some force. Say he is applying a 10 Newton force. But is the wall going to move?
No.
No. Means the distance is zero or the displacement is zero. So according to the formula W equals to F into S, it will become F into zero and it will give us 0 joule. So we will say that according to physics, that boy hasn't done any kind of work, right? Okay. This is one of the case. Second is work done by a force is zero if the force is perpendicular to the displacement. Okay. Like in this example, you can see perpendicular means what? Making 90 degree if when a force makes 90 degree with the direction of displacement. For example, suppose this boy is lifting this block. So to lift the box, he's applying a force in where? Upward direction, and then he's walking. So if he's walking, the block is moving forward this. So can you see what is the angle between these two forces? The force is acting upward and the direction is horizontal. So the angle between them is what? 90.
90
Angle
degree.
between them is 90. It means the force, it means between the direction of, sorry, what we can say? That force is perpendicular to the direction of motion. Understood? So for such cases, the work done is considered 0. Work done is considered 0. Okay. Here also you can see a figure in which a satellite is revolving around the earth. So we know that on a satellite, the force acting is the gravitational force and it is towards the earth. And the direction of satellite is always in the direction of tangent. This we have studied in the previous chapter. Okay, in the gravitation. So ये tangent का direction ये होगा. So here also we can say that see that the angle between these two is 90, means they are perpendicular to each other. So even here, if it is asked that what is the work done by gravitational force on the satellite, so what we will say? It is 0. We will say that it is 0. So here is a formula which you will be using in higher standards, but just for information I am showing you the formula. It is W equals to F cos theta. This is one more formula where theta is the angle between the two force. Theta is the angle between the two force. Okay. And when it is perpendicular, so this theta becomes 90. So it becomes cos 90. And here, whatever may be the value of force, suppose we are applying 10 Newton force and the body moved by say 5 meter. अगर ऐसा है, then this 10 into 5 will give us 50. But the value of cos 90 is 0. You will learn this. What is cos? It is a trigonometric function that you will learn in 10th standard. So value of cos 90 is 0. So whatever may be the values of f and s, the final value is going to be 0 joule. It is going to be 0 joule. Understood? So this is the reason why the work done becomes 0 when the force is perpendicular to the displacement. Okay. Hope it is clear to everyone.
Sir.
Now the next question. There's an example. See, it's given that when we lift an object, suppose you are lifting a bag or a suitcase from a ground, the object moves upward in the direction of force. This is true, right? So if it is asked that what is the work done by the force that we have applied to lift the object upward, so in that case the work done would be positive क्योंकि हमने force का apply किया ऊपर की तरफ और body भी काम हो रहा है upward. So work done is positive. But at the same time, the force of gravity is also acting on the object which is in downward direction. So work done by the force of gravity is negative. Understood? So at the same time, it can be both. Okay? Understood?
Yes.
Okay, so the next one is this one more example. See, a potter lifts a luggage of 15 kg from a ground and puts it on a head. Okay, you all have seen that potter or the coolie, we can say. Okay, if suppose they have lifted a luggage and kept it on the head at the height of 1.5 meter, we have to find the work done. Okay, so see, we know the formula of work done. W is equals to F into S. Formula क्या है work done का? W equals to F into S. Do we have the value of S? It is 1.5 meter that we have. Correct? Do we have the value of F? No, directly it is not given. So we know one formula, that is F is equals to mg. Okay, so by using this formula we can find the force and then we can keep the value. The value of m we know. The value of m we know, it is 15 kg, and the value of g, approximately it can be 10 meter per second square or it can be 9.8 meter per second square. So on putting that value, we will get 225 joule. Okay, so this is how we can solve this numerical. Understood, all of you?
Yes, sir.
Okay. Now the next topic, that is energy. Tired. Okay, we will get tired. Why? Because the energy would be lost by our body. Energy would be lost by our body. So an object can gain energy or it can lose energy depending upon the work done. Depending upon the work done. Means if suppose an object, say a trolley is there on the floor, it is at rest. It is at rest. And what you did, you applied a force on it. You applied a force on it. So who did the work? You did the work on what? Trolley. You did the work on trolley, and because of that the trolley started moving. So who lose the energy in this case?
You.
We. That is means the person who is applying the force, they will lose energy. उतनी energy उनके bodies में से कम हो गई. And who gained the energy?
Trolley.
The trolley gained the energy. So what we can understand from this, that whenever a work is done, the energy get transfers from one body to another body. From one body to another body. Understood? So the energy can be gained also, or the energy can be lost also. Now, if an object does some work, it loses its energy, and if some work is done on an object, it gains the energy. Okay, and this statement is clear from this example of trolley. Okay, now as we discussed that the energy is just a capability of doing work. It means जितनी energy होगी उतना ही work done वो करेगा. Okay, so that is why the unit of energy is same as that of work, and that is joule. So this you have to remember, that for both the quantities the unit is same, that is joule. Okay, now it is very simple. If suppose 1 joule of work is done on an object, if 1 joule of work is done on an object, then how much energy has been applied on that object, or how much energy has been used? 1 joule. मीन्स अगर हम 1 जूल एनर्जी यूज कर रहे हैं तो वर्क डन भी कितने का होगा? 1 जूल का होगा. इफ सपोज अगर हम लोग 10 जूल एनर्जी यूज कर रहे हैं, सो वर्क डन भी कितने का होगा? 10 जूल का होगा. सो दे बोथ रिमेन सेम, बिकॉज जितनी एनर्जी होगी उतना ही वर्क डन होगा, राइट? The bigger units are kilojoule. Okay, and we know that 1 kilojoule is equals to 1000 joule. If there is a word kilo, it is going to be 1000. Okay, understood? Okay. Now, so this was the understanding of energy, or the relation between energy and work done. Now let us discuss the different forms of energy. So as we know, and you all have also studied about different kinds of energy. So there are generally different kinds of energy. For example, heat energy we have studied, light energy we have heard, electrical energy, chemical energy, mechanical energy. Okay, from sun we get light energy. Okay, from machines, say from a vehicle or from lot of machines we get mechanical energy. When we burn something, it's a thermal energy or a heat energy we can say. There is also sound energy. From a cell we get a electrical energy. Okay, here it is nuclear energy from a nucleus. Understood? So there are various kinds of energy. But in this chapter, we will be discussing only 2-3 types. So first we will discuss the kinetic energy. First we will discuss about the kinetic energy. Now what do we mean by kinetic energy? So kinetic energy of an object is the energy possessed by the object due to its motion. Means if anything is in motion, it possesses a energy, and that energy is known as kinetic energy. Okay, so all the moving objects possesses kinetic energy. For example, suppose if you start running, then even your body will have kinetic energy. If a ball is thrown, that moving ball will have kinetic energy. So here are a few examples: a falling coconut, a speeding car, a flying aircraft, flowing water, blowing wind, running athlete, etc. They all possesses kinetic energy, right? So you all have heard about the windmill. Okay, so what does the windmill does? It uses the kinetic energy of blowing wind. This is the kinetic energy of blowing wind. Okay, so these are few examples of kinetic energy. And the kinetic energy of an object depends on its speed. It means what? If a speed is more, if object is moving faster, it has more kinetic energy. Okay, and if it is moving slower, it has less kinetic energy. It is very simple. See, suppose say that if a car with a speed of 10 meter per second hits an object, and another car which is, or we can say that the same car, in second case, if it hits an object of if it hits an object with a speed of 100 meter per second, so in which case the damage would be more, or the effect on that the other object would be more?
100 meters.
In case of 100 meter per second, when the velocity of the car is 100 meter per second. Why? Because agar velocity ज़्यादा है, so the kinetic energy would be more. So if energy is more, the work done by that car would be more. तो वो जिस भी object को so to whatever object the it is going to hit, the effect on that body would be more, means the work done on that body would be more, क्योंकि energy बहुत ज़्यादा है. So what we can say, that it depends on speed. अगर speed ज़्यादा, so energy would be more. If speed is less, the energy would be less. Okay. In figure also we can see few examples. Arrow released from a bow, flying through air, even it has kinetic energy. If it hits something, it can pierce it, means because it is having some energy. Similarly, a cycle rolling down a hill, it will have some energy because it is in motion. Similarly, athletes running, a car moving, this all have a kinetic energy in it. Anything which is in motion, it will have kinetic energy. Okay. And if something, or if suppose it hits some object, so it will produce some effect, or it will do some work on that object. So this is what happens in case of accident. So if we are driving slow, so the kinetic energy is less, and hence if an accident occurs, then the damage is also less because the work done on the body is less. Understood all of you? Okay. Now